Guys, my name is Anthony Nathaniel, and today we are going to be dealing with another concept in further mathematics, which is called the straight line. And we want to talk about the straight line. The straight line is a kind of topic in further mathematics that has to do with the Cartesian plane, has to do with the properties of the a line, straight line, and it deals with a lot of concepts that we will be dealing with in this particular video. So we have some performance objectives. There are some things we need to have achieved in this by the end of this video, and first of all, we need to have at the end of this video, we need to have understood the midpoint, how to calculate the midpoint of a line, how to get the gradient of a line, distance between 2 points, condition for parallelism, the equation of a line, non-linear relationship, and so on and so forth. A lot of concepts which you need to have grasped by the end of this video, and I hope you end up understanding these concepts by the end of this video. So without wasting much time, let's delve into the middle aspect. So let's talk about Cartesian coordinates first. So I want to talk about Cartesian coordinates. Cartesian coordinates, they are basically the position of a point in plane as noted by its distance from the x and y axis respectively. So basically the position of a point in a plane is conveniently specified by distances from two perpendicular lines, and the lines are the x-axis and the y-axis. So that's what I need you to understand. So basically we deal with these distances a lot. These distances, they are very, very important and instrumental to understanding of the straight line. So basically, let's move on to something else. And now this x and y coordinates, their point of intersection lies in a particular point on the Cartesian plane known as the origin. Yeah, origin. So basically, that's basically the fundamentals for you to understand when talking about the Cartesian plane. And once you understand that, we'll be moving to the distance between 2 points. Now, the distance between 2 points is basically a concept that is a mathematical calculation by which we estimate the distance between 2 points, and that is basically, that depends on the particular formula here. So we have a formula for the distance between 2 points, and that is given by but first of all, let's look at the fundamentals, the background of that. So looking at it from the fundamental point of view, you have distance between 2 points. We have x1, y1, x2, y2. So if p, q have coordinates x1, y1 and x2, q, y2 respectively, so p is the x1, y1, q is the x2, y2. So in this case, we have pq equals to pr squared plus rq squared. Obviously, that is basically a stem from the Pythagoras' theorem. So you can see that Pythagoras' theorem is also having a very important application in Cartesian coordinates geometry. So we also have that when we convert that into their symbols, we have pq because of the square root of x2 minus x1 squared plus y2 minus y1 squared. So that is one concept you need to understand. And from this concept, we'll be going to an example. So there's an example which we need to understand. So basically, the first example is basically on the screen here. So we have it on the screen here. So we have find the distances. We're asked to find the distances. So these distances, they are distances between points. They are pairs of points, actually, pairs of points on the Cartesian plane. So you have A is 3,2 and B is 4,6. Now, in this first example, you say let D be the distance between A and B. So then D1 equals D. So you use that same formula, that's x2 minus x1 squared plus y2 minus y1 squared. So in this case, x2 belongs to B, which is 4, and minus x1 belongs to 3, which is 3. That's 4 minus 3 is squared. Then plus y2 minus y1. Y2 belongs to B, which is 6, and y1 belongs to A, which is 2. That's 6 minus 2 squared. At the end of the day, you get the square root of 1 plus 16, which is the square root of 17. Now, I need to understand that these square roots, they are not always whole numbers, because they are just not meant to be whole. Because mathematics, many things are not just meant to be the way you understand it to be. So if you don't get whole numbers, you might still agree with yourself as a correct answer. So let's talk about the midpoint of a line segment. So basically, the midpoint of a line segment is basically a point in the line which is at equidistant from its end. That's what's known as the midpoint of a line segment. Now, considering the concept of midpoint of a line segment, there are different calculations we can perform with that. So we have from P and Q have coordinates x1, y1 and x2, y2 respectively. Let's R with coordinates x, y be midpoint of PQ. So as PRS and PQT are similar, so PR over PS equals RQ over SC, obviously. And then we have x minus x1 equals x2 minus x, because that is a distance between because you know that let let R be coordinates, x comma y be the midpoint. So because it's the midpoint, so its distance from the end will be equal. So that means x minus x1, which is the midpoint, will be equals to the x1, x2 minus x, which is also the midpoint. So then we have 2x equals to x2 plus x1. At the end of the x equals to x1 plus x2 over 2. So similarly, y equals to y1 plus y2 over 2. So that is why the midpoint is half the sum of the x coordinates of the ends of the line, comma half the sum of the y coordinates of the end of the line. That is the coordinates for the midpoint of a line. So in general, that's basically how it was, and that's the that's how the equation was gotten. Just in case you've been wondering how did they get this equation in mathematics, so that is how it is gotten. And then moving on to another concept, let's go on to the division of a line into a given ratio. So when we talk about division of a line into a given ratio, it is a concept that that's quite it's not very understandable in at first, but basically it's very important because we say A divides PQ internet in the ratio 2, right? Now basically, anytime you have the ends of a line and division, the segments division are inside the line, then you call it an internal division. But when that segment, one or more of the segments, okay, let's say when one of the segments is outside the line, it's called an external division. So, but in both of these cases, they are actually similar, and we get the same mathematical result as a result of that. So this division of line is quite similar. All you need to do is you make it of the ratios. So 3 over 2, and that's just a ratio that you need to know for the calculation. So moving on to another concept, we have the next concept in this video on Cartesian planes. Here we have gradients. Yes, I like this topic, so which is why I'm teaching it with a lot of enthusiasm. So when we talk about gradients of the line, the gradient of the line is basically the rate of change of a particular axis with respect to another axis. So specifically, the gradient of a line is the rate of change of the y-axis with respect to the x-axis. So basically, the gradient of a line is defined as the ratio of increase in x to the increase in y, as you can see on the screen. So basically, in going from one point to another on a line, you would come across a slope. So the gradient is how, like when you are walking down a hill, if the hill is quite steep, you be going with a lot of acceleration, right? But if it's on level ground, there's no change in the steepness in the fall. Let's call it fall. There's no when land goes down, it's a fall. When land goes up, it's a rise. So there are no falls and rises. There are no what's the name for those potholes? Yes, a quite embarrassing name. Yeah, potholes. So now basically, when you have no potholes, your gradient becomes 0. But when you have potholes, your gradient becomes other than 0. So gradients can be positive or negative depending. And if you don't understand the concept of gradients, I've done a very comprehensive video on this channel on gradients. You can check it out. Just ransack the numerous playlists on my channel. You can check out a lot of educational content in mathematics, especially mathematics and technical drawing, because when I was in secondary school, that was my major focus. I was very good in this subject, mathematics and technical drawing, so, and also further mathematics. So you can check out those contents. You will definitely be satisfied with those contents, what I've produced in those contents. So moving on, let's go on to another concept on in this topic, and that is angle of slope. So angle of slope. Okay, angle of slope, you can also check that in the course in my channel. I've done that. Angle between two lines. So basically, there are different concepts which we'll talk about angle between two lines. But okay, let's talk about angle of slope first. Angle of slope. When we talk about angle of slope, it is basically the angle by which the line slopes downwards. So basically, in this figure, we have the line PQ makes an angle with the positive axis, and A is called the angle of slope of the line. So basically, you have an alpha. So in this diagram, you have an angle alpha. So that angle is called this angle of slope, and it's basically the tangent of the triangle that is drawn, triangle PQR. So the tan alpha, which is the angle of slope, tan alpha is equals to the ratio of the opposite to the adjacent, which is the tan. So tan alpha, literally explanatory. So then let's talk about the angle between two lines. Wow. So it might look so quite unwieldy, but angle between two lines is something that it's quite interesting, because this angle between two lines can be used in a lot of concepts. So, and it's also interesting for you to know what angle is between two lines when you just see lines and it looks quite unexplanatory. Mathematics tells us a lot of things about Cartesian geometry. In my opinion, I think one of the most wonderful aspects of mathematics lies in Cartesian geometry, and that's what we're about to explore today. Now, we have angle between two lines, and the angle between two lines, we have that lines AB, which has a radius m1, and CD, which has a radius m2, make angles alpha 1 and alpha 2 respectively with the x-axis. Now, the acute angle between the lines is alpha. Yes. So now tan alpha 1 is m1. So from this diagram below, I said the tangent of the angle of slope is equal to the gradient of the line. So because that gradient is equal to the rate of change of y with respect to x, and that is the same thing as opposite over adjacent. So and then that's tangent alpha 2 is equal to m2, obviously. But then we're looking for the angle between the two lines, and that is equal to alpha, right? So moving on, we have that obviously we have in the exterior angle of triangle PQR, alpha 2 equals alpha 1 plus alpha, then alpha equals to alpha 2 minus alpha 1. So basically, when you have two lines, you are basically looking for the difference in their slopes. That's where you get the angle between them. So at the end of the day, tan alpha equals tan alpha 2 minus alpha 1. Then when you make it of the tan angle formula, you have tan alpha equals tan alpha 2 minus tan alpha 1 over 1 plus tan alpha 2 tan alpha 1. So this is one formula in further mathematics that we often apply. So we don't need to talk about the derivation because that relies heavily on a lot of, what will I call it, of classical trigonometry, or let's call it traditional trigonometry, which we don't want to talk about today. It takes a lot of time to talk about that. So this formula here is for the angle between two lines. So it's basically equals to the difference between their gradient divided by the one added to the product of their gradients. So that's the best way to put it in English and syntactical terms. So that being said, let's move on to another concept, which is conditions for parallelism and perpendicularity. So basically, for a line to be parallel to another line, their gradient has to be equal. Because why? Because you need their slopes to be the same. So that means if one is sloping like this, the other is sloping like this. So they must be going in the same direction, which means they must be parallel to each other. And in such a way, there's no change between their lines. Yeah, there's no angle between their lines. That means if you plug in the values of 0 for the angle between their lines, so 0 equals m2 minus m1 over 1 plus m2 m1. So at the end of the day, m2 minus m1 equals 0 and m2 equals m1. That is why m2 equals m1. So, but if you're talking about perpendicularity, you are plugging a value of 1. Why? Because the angle in the tan of an angle of a right angle is 90 degrees. Because when you talk about perpendicularity, you're talking about a right angle, right? So the tangent at a right angle is 90 degrees. That's why so that means, and the tan of 90 degrees is actually infinity. So that's 1 over 0. When you compare, you get 1 plus m2 m1 equals 0, and at the end of the day, you have m1 equals to minus 1 over m2. Now, this concept, as simple as it may be, they are very, very widely applied in mathematics. They are very, very widely explored. And I was reading a particular text in engineering mathematics last year. Was it last year? Yes, actually, it was 2 years ago, 2021. This around October 2021. And wow, how time flies! God, we're already in 2023, right? Now, when I was reading that text, I was actually getting some dramatic reminiscence into this secondary school aspect of further mathematics, which shows that mathematics is actually a sequential chain, just like life. Anyway, let's move on to another concept in this topic, and the next concept we'll be dealing with here is okay, obviously the next concept we'll be dealing here is equation of a line, because equation of a line is very important. So when we talk about equation of a line is a concept that is often that always needs to be addressed. So the equation of line is the relationship between the coordinates of a variable point, which lies in focus, and the equation of a straight line, for that matter, is a relationship that exists between two coordinates of x and y of a variable point P on the line. So basically, the equation of a line is basically the relationship between the coordinates and a variable point. So the variable point is x and y. So the coordinates are basically the slope of the line is often that constant or is functionally related to the variables. So you are looking for the gradient, and that is related to the coordinate of that line, which is the variable, and then it is either constant or functionally related to those same variables. So I hope you understand this concept I'm saying. So if you don't, we'll still talk about the examples on that. So now let's talk about let's move on to the next concept, which is different forms we can express the gradient. So we have the gradient intercept form. So the gradient intercept form is a form which you can express the gradient of the line. So in this case, all you need to do is you need to say that let a equals x comma y, and that will be any variable point on the line pq. So if the gradient of pq is m and the intercept of the line on the y-axis is c, then y minus c over x equals m. So the reason because y, the difference between the y and the c is the length of on the y segment, and then the x is the x segment, and that's equal to the ratio of that is equal to the gradient of the line, as we mentioned earlier, because that is the rate of change of y with respect to the rate of change of x. That is why we're dealing with quotient or ratio. Now, at the end of the day, we have y equals mx plus c. Now, there are different ways of expressing the gradient of the line. Different form. We have the gradient intercept form. We have the gradient and 1 point form. We have the 2 point form. We have the perpendicular distance from the origin form. We have the general form. So we'll be skipping to the general form, which is one that okay, the general form is actually one that is quite interesting because we need to understand it in detail. So let's understand the general form, because from general form you will be able to derive other forms from general forms. You understand it. So let's move on to general forms. I want to talk about general forms. General forms is we have a lot of things to discuss when it comes to general forms. So first of all, we have to consider different formats of the equation of a line. So at this stage, we have that we have y equals mx plus c, which is the first stage we've covered. We have the y minus y1 equals mx plus minus x1. That is the gradient and 2 point form. We also have the y minus y1 equals y2 minus y1 over y2 x minus x1 x minus x1. So that is 2 points and gradient form. So at the end of the day, we have another form, which is the perpendicular form, axis form, cos alpha plus x cos alpha plus y sine alpha equals p. So that one is a less popular form, which we don't deal with most of the time, but it's still useful. It will still bail you out of different mathematical loopholes you might find yourself in an examination. So and then to observe that each equation is a linear and linear or first degree relationship between x and y. So that's what we observe, and then therefore an equation of the form ax plus by plus c equals 0 may also be called the general form of the equation of a straight line. The general form may be transformed into other forms by suitable rearrangement of the forms. So for example, we can say ax plus by plus c equals 0, by equals minus ax minus c, y equals minus ax over b minus c over b, so on and so forth, and that is called the gradient intercept form. So basically, this is an exhaustive episode on gradient intercept and all the rest. I hope you've understood this concept, and hopefully I want you to understand that these videos are meant to give you a basic understanding of this concept so that you'll be able to deal with them theoretically. But when it comes to the practice, I always tell my students that when you've taught you the theoretical aspects, you should still go in your closet and practice them out, and let's see how much you can tweak your brain and give yourself a challenge. So that being said, we have invariably come to the end of this course, and at the end of that this course, we have a summary. So there are some concepts which we've talked about in this course, and I want to revise with you guys. So I want us to have a revision of what the concepts we talk about. So first of all, we'll talk about the distance between 2 points. So this is summary. You can take a snapshot of the summary in case you've forgotten what we talk about. Talk about the midpoint, the formula for calculating the midpoint, the points which divide in the ratio PQ. So that's the formula for it. Though I might not have mentioned it in the video, but that's the formula you can write in your notes, and you can kind of have it somewhere at the back of your head. Then you have the gradient, formula for the gradient, and then the acute angle between two lines. Now I'll continue to stress the angle between two lines because it is a concept that you keep talking about in not just in coordinate geometry, but when you talk about vector or algebra, you also need to understand that concept. When you talk about scalar products, vector product, and you will mostly be dealing with the angles between lines. So I hope you've enjoyed this topic. If you've done, Don't forget to like, share, and subscribe to this channel. And I hope to see you next episode.